Hello and welcome back to Stopping the Algorithm. Today we begin our journey into multiplication. Now the technique I'm going to show you takes a while to get used to sometimes, but trust me, it sets you up for success when it comes to areas in geometry, when it comes to distributive properties, and particularly when it comes to algebra. And if you get used to this process, it really just makes it so that you can do everything better, including the mental math. Because even though we're going to be doing it with a different format, it's still thinking left to right, top to bottom, and I'll show you that in the second round. Today I'm going to keep it fairly straightforward though. So let's say we were going to do one like 36 times 27. In the old technique, you would start doing 6 times 7, carry the 4, and this would get very, very busy. I'm not even going to show you how we do it. I'm going to show you a new technique. Now this introduces the idea that every multiplication problem is an area problem. So we're already thinking about geometry. So on this side, and it doesn't matter which side you put which one, I'm going to put the 36 and the 27. So then this box just becomes an area that's 20 by 30, which is 600. This box becomes 7 times 30, which is 210. 20 times 6 is 120, and 6 times 7 is 42. Notice the other nice thing about this is it's nice and clean. You're not crossing out, doing weird things, but then when we add it up, we just go top to bottom again. 600, 210, 120, and 42, and add them up left to right. 972. You can also do the exact same thing. Let me change the color so you can see the exact same problem. Oops, like this. And this has been presented to a lot of kids as diagonal math. So we just write 3627 implicit in the columns. But then what's going to happen is this becomes your ones column, tens, hundreds, and thousands. Now you understand why it's called diagonal, because instead of looking at it straight up and down, we look at it diagonal. So 3 times 2 is 6, 0 thousands, 600s. 7 times 3 is 21. 6 times 2 is 12. And 7 times 6 is 42. Now we just add up our columns. 0, 1, 6, and 2, 900. 2, 4, and 1, 72. Doesn't take up any more space than this did. And doesn't have any crossing out, doesn't have any carrying, and it's still talking big to small. You can see immediately how you're going to go. Let's do one more both ways so you can see it, and we'll talk more about how this translates into mental math. You can already see how this translates into geometry, that even if you had a weird shape like this, you're already thinking in compartments, that you can break things down and find the area here, the area here, and the area here, and then add it up. So it's setting you up for a lot of success. Let's do one more problem. I'll see if I can find that purple color again. And this time, let's do 54 times 31, just so you can see how this works again. So 54, 31. Oh, well, let's start this way. So 50 times 30 is 15 and 2 of those, so 1500. 1 times 50 is 50. 30 times 4 is 120. And 4 times 1 is 4. So 1500, 120, 50, and 4. And your answer is 1674. If we're going to do that using this one diagonally, we implicitly know that this is the 50 and the 30, so I just leave it at 5 and 4, 3 and 1, and we get 15. Make that diagonal. 5, 2 times 4 is 12. And 1 times 4 is 4. 1,600 and 574. Takes some getting used to, But let me tell you, when it starts getting to algebra and geometry, and I'll show you how that works in a few more episodes, you are going to love it, particularly compared to this thing. Okay, so there you go. Math in a box when it comes to multiplication. Good luck. God bless. Talk to me with questions on anyonecandomath.com.